All right, let's talk about one of the biggest, most frustrating problems in AI today. Why do these models just make stuff up? Well, there's a really clever solution called Retrieval Augmented Generation. We just call it RAG. And the easiest way to think about it, it's basically like giving an AI an open book during an exam.
So why do these super powerful large language models hallucinate? Just invent facts out of thin air? Well, it really comes down to what you could call the frozen brain problem. See, an LLM's knowledge is basically locked in time. It's frozen the moment its training is finished. So when you ask it something, it's not thinking. It's trying to perfectly remember a fact from this gigantic static library in its head. It's a pure memory test. And just like us, sometimes it remembers wrong.
Okay, so this right here is the core idea. On the left, you've got your standard LLM. Think of it like a student in a closed book exam. They have to rely completely on what they've memorized. And we all know how that can go, right? High risk of just getting it wrong. But on the right, you have RAG. This totally changes the game. It's an open book exam. We're not asking the AI to remember anything. Instead, we're handing it the textbook, pointing to the right page and saying, hey, read this and tell me the answer. The jump in accuracy is, well, it's huge.
In this open book idea, it's not just a cute analogy. It's a complete change in what we're asking the AI to do. We're shifting the entire workflow from remembering to reading. So how do we actually build a system that can do this?
Okay, let's look under the hood. The best way to understand a RAG system is to think of it as a team of two specialists, a really good librarian and a really good writer. And they each have one very specific job.
And here's the whole pipeline. The caption on this slide just nails it. At its core, RAG is basically a search engine taped to a chat engine. So a user asks a question. First, it goes to the retriever, that little claw machine there, which digs into a knowledge base and pulls out the most relevant piece of text. But here's the magic trick. That piece of text, that context chunk, gets stuffed directly into the prompt before it ever gets to the main AI. We're giving it the answer before it even speaks.
So let's talk about that first part, the retriever. This is our librarian. Its only job is to search through all the information we've given it, usually in something called a vector database, and find the most relevant snippets of text. It's not just matching keywords either. It's matching the actual meaning, the semantic similarity of the question. But, and this is super important, it doesn't understand a single word it's looking at. It's just a phenomenally good pattern matcher. It just finds the right page in the book.
Okay, so once our librarian finds the right page, it hands it off to the generator. This is our writer. And the generator, well, that's the large language model you already know. But it has very strict instructions. Read only what I've given you and build your answer from that. Nothing else. It is completely boxed in by the facts it was just handed. And that's the secret sauce. That's how we stop the hallucinations. Theory is one thing, but let's see how this librarian and writer team actually works in the real world. We're going to walk through a quick case study with a fictional airline, Skystream. And it involves let's say, an unconventional travel companion.
So step one, it always starts with the user's question. Someone opens up the Skystream app and types in a very specific query. Can I bring my iguana in the cabin?
Okay, the moment they hit enter, our librarian, the retriever, gets to work. It instantly scans the entire Skystream knowledge base, and boom, it finds the perfect document. Section 8.4, Reptiles and Amphibians. The system has found the one single source of truth for this exact question.
Now, this next part is the most important step in the whole process. It's called augmentation. Behind the scenes, the system builds a brand new prompt. It takes the user's original question, can I bring my iguana, and then it stuffs that chunk of text it just found from section 8.4 right in there with it. It's literally injecting the correct answer into the question before the AI even gets a chance to think.
And finally, that big, combined prompt gets sent to our writer, the LLM. So what does the LLM do? It just reads. It sees the rule about no reptiles, it sees the question about the iguana, and putting two and two together is easy. It generates a perfectly correct, helpful answer. And the key again is that its answer is based only on the facts it was just handed. No guesswork involved.
And that's the real payoff right there. What you get isn't just a random guess from some old training data. You get an answer that is 100% grounded in fact. You can even cite the exact document it came from. And for a business, like an airline, this is everything. It means the answer is legally defensible. That reliability is why RAG is such a game changer for enterprises.
Okay, so for all of you out there who are actually building these things, the engineers, the system architects, listen up.
There's one golden rule for RAG that you absolutely have to remember. It's more important than anything else.
Here it is, plain and simple. Retrieval quality is always more important than generation quality. Always. Think about it. You could have the most brilliant, eloquent LLM in the world as your writer, but if your librarian brings back the wrong book, what's the point? The whole system falls apart. It's the classic garbage in, garbage out. The quality of your retriever sets the absolute ceiling for how good your entire application can be.
So this whole pipeline we just walked through, it's perfect, as long as the retriever gets it right. But what happens when it grabs the wrong page? What if, for that iguana question, the retriever had pulled up the policy on the size of carry-on luggage? The system would just as confidently spit out a totally wrong, nonsensical answer. And making sure that retriever is truly world-class, well, that's the single biggest challenge in building these systems in the real world. And it's a much deeper topic for another time.